Okay, in these kind of short series of videos, we're going to look at solids, liquids, and gases. And we're going to start off with gases, okay? And when we look at gases, we have to talk about the kinetic molecular theory of matter, or I should call it KMT. All right, what it is based on the idea that particles are always in motion. And we can actually use this kinetic molecular theory, which just means a theory about how molecules move, because kinetic energy is like energy of movement. Okay? And it also helps us understand the behavior of gases, and it actually describes what we call an ideal gas. We'll talk a lot more about ideal gases and some more specifics with that later on in the year. Right now, we're going to talk about the 5 assumptions of the kinetic molecular theory, which means the 5 things that we assume about gases and how they work. Okay, the first one is that gases have large numbers of tiny particles that are far apart relative to their size. So that means you've got lots of little particles, okay, they're really small and they're very far apart. Okay, the second one is that collisions with particles in your container are elastic. What that means is kind of like a rubber band is very elastic. Okay, when they bounce off of one another, they don't transfer any energy. We really don't get into that a whole lot, but just remember that they always kind of bounce off one another. Okay, number 3, particles are in rapid random motion and they possess kinetic energy. And again, like I mentioned a little bit ago, kinetic energy is the energy of movement. Alright, number 4, there's one more after this because there are 5. Okay, there are no forces of attraction or repulsion between particles. And that just means as these small particles that are very far apart are colliding with one another because they're moving around rapidly and randomly, they don't stick to one another. We're going to assume that they just hit, they bounce off, they go other directions, and they're not being pulled towards one another. Okay, the last one then is that your average kinetic energy, and I usually write kinetic energy as just Ke, okay, your average kinetic energy depends on the temperature of the gas. So if you have a higher temperature, you're going to have more kinetic energy because they're moving. I always think that they're moving faster. Okay, if you're at a higher temperature, things have more energy, they're more excited, they've got more energy to move, so they move around a lot faster and they have a lot more kinetic energy. Okay, so now we're going to look at some properties of gases, okay, which you probably have covered in middle school. And the first property of a gas is that it has no definite shape or volume, and they tend to take the shape of their container. Gases are not just going to stay in one area of a container, they're going to fill up the entire container. And usually you see gases drawn like this. There's my container, I have little particles, and I have them everywhere. Okay? Gas particles easily slide past one another, and they're very far apart. Gases are also very easily compressed because there is lots of empty space. Okay, the next thing now we're going to look at is the difference between diffusion and effusion. Okay, because gases do both of these. Okay, if a gas has diffusion or diffuses, if you think about a candle, okay, sitting out on a desk, if you light the candle, after a while the room starts to smell good. That is diffusion. Okay, diffusion is where gases will just uniformly mix, okay, without having to stir them at all. And heavier ones tend to move slower, lighter ones move faster. Okay, effusion on the other hand, okay, is not as common. Okay, they use this more in experiments and in lab to kind of test for different how fast gases move, because diffusion is harder to measure. Okay, unless it's small because you really can't see the gas. So what happens is they do what they call effusion, and this is where particles pass through a small opening, usually from one end to another. And tires filling up your tire with air is a good example of effusion. Alright, we're going to look at an experiment between hydrochloric acid and ammonia. Ammonia is NH3. We'll talk more about this later on in the year. Okay? But right now we're just going to consider them to be two gases. Okay? And if you put these two things together, they make a white solid or a white precipitate. Okay? So we're going to have a long tube here. Okay? And at one end, we're going to put some hydrochloric acid. And at one end, then, we'll put some ammonia. Okay, ammonia is something that smells very strongly. Okay, it's what usually makes cat pee smell pretty bad. Now, what you do is you kind of soak two cotton balls, okay, in each one of these. Okay, you stick it in the side of this open tube, all right, and then you let it kind of just mix because the gases over here will start to move. The liquid that's in this will turn to a gas and start to move this way. And what you'll end up seeing, okay, is that the white solid will form somewhere very close to the hydrochloric acid. And the reason being, okay, and we'll get into this later on in the year, how you can tell which one's heavier, but hydrochloric acid is a heavier molecule. Okay, so it doesn't move as fast. So the ammonia, the NH3, moves so much faster that when NH3 and HCl meet to make this white solid, it's much closer to the acid. Okay, so this is a good example of diffusion, okay, and it's an easy way to see this diffusion and to know that hydrochloric acid is heavier because it's closer, the solid formation is closer to the hydrochloric acid.